Hi, I fooled y'all. We're not quite yet going into examples. So in the last video I gave you some basic equations. There's one more basic equation I want to go over before we do examples, just to wrap up this section. So if you look behind my shoulder, we have this integral with respect to f, dotted, so there's a dot, it's the dot product, okay? Dotted dr. So this r is a bold r, okay? And this is the curve C. Now, here's a new way to think of it. So rather than xt, yt, you just put the whole thing as a curve r, right? So r is just the vector version of x and y, okay? Nothing too complicated, or x, y, and z if it's in 3 dimensions. So you have x, y, and z. Here it is. And then this r prime t dt, that's just your differential, right? So in the previous video, I said that's going to be the square root thing with the sum of the squares, right? The square root with the sum of the squares. It's the same thing. This is just another way to think about it. Here, this is a type of calculation that we're not really going to favor that much in this course, but this is another way of thinking of it. So there's this thing, t, called a tangent, the tangent vector, and I haven't really discussed that in this course, but basically along a curve, right, along a curve, if this is C, and say this is a point, right, this vector shooting off like that, that's t, okay? So it's a unit vector, meaning its length is 1, and this is just another way to think about it. There's still yet another way to think about this equation, and this is on page 1124, and it says that you can rewrite this as the integral over c of p dx plus integral over c q dy plus the integral over c r dz, right? Where f is p, q, and r. Okay, so f has components. Okay, it has the first component, which is p, your x component. It has a second component, which is q, and a final component, which is r. Now, each of these we know how to compute, right? I know how to compute the integral of p over c with respect only to x, right? So you might say, what's the point? What's the point of doing this? Well, it's always good to have more than one way to do a problem. So here we've split that integral up into 3 components. So ultimately, okay, I'm not going to do the proof. You can look at it. It's on page 1124. But the idea is it's just linearity, right? The integral is linear and vectors behave in a linear fashion. So because both of those objects are linear, we can split it up into its component parts. And we could, in principle, compute the integral over each part. At times, there will be different ways to think about these problems, and at times, one way is better than another. Okay, I promise in the next video, we'll start doing some examples. No more gotcha moments, okay? Be right back.